Good morning, everyone. I'm Naoko Matsumoto, the director of the Research Institute for the Dynamics of Civilizations, Okayama University, and the PI of the Out of Eurasia project. I'm very much excited to start this symposium, Human Dispersal from North Eurasia via Beringia to North America. First, I want to thank Dr. Potter for organizing this wonderful symposium with us and all the speakers from around the world. I'm delighted that all of the 6 participants from abroad have safely arrived in Japan. During the long COVID-19 pandemic, most international meetings have been held online, so I'm delighted that we are now physically in the same room and can have direct communication and discussion. This symposium is planned as a part of the research activities of the project Integrative Human History of Out of Eurasia, which is supported by granting aid for scientific research on innovative areas. It is a very ambitious project in terms of its transdisciplinary nature and geographical scale. The project focuses on the human being, which links nature and culture, mind and matter, and on human action and cognition, to understand the uniquely human nature that produced the so-called civilizations in many parts of the world. Our research strategy is to compare the mutually independent niche construction processes between the Americas, the Japanese archipelago, and Oceania. The regions of the final destination for Homo sapiens who left Eurasia and dispersed by overcoming population bottlenecks and extreme environmental conditions. For this research agenda, it is essential to investigate how, when, and who migrated out of Eurasia, and the human dispersal from North Eurasia via Beringia is one of the most crucial targets of our study. Clarifying this issue requires interdisciplinary exploration, including archaeology, biological anthropology, and molecular anthropology. Please correct me if I'm wrong, but I think there has never been such an opportunity to bring together so many archaeologists and geneticists specializing in this topic to discuss how and when migration to the Americas took place, and how these people adapted to the cold climate and new environments. After 2 days of presentations and discussions, I believe that everyone here will arrive at a new understanding of the theme of this symposium. Thank you very much. And now Dr. Honda, who is one of the organizers of this symposium, will give an introductory remarks. Please go ahead, Dr. Honda.
May I speak here? Please allow me to be seated. Good morning, everybody. In my presentation, Human Dispersal from North Eurasia via Beringia into North America is the title. Well, some people may not know a lot for Beringia or people other than the disciplines of the archaeology and so on. I would like to present the basic themes for the introduction for the audience. In this symposium, what was the starting point? Let me explain. Well, dispersal into the Americas, eastward progression out of Eurasia. That was the presentation made at the plenary meeting of Out of Eurasia. It was held in 2020, and this subject chosen as one outreach event of Out of Eurasia project. The delivery or the outcome should be contributed back to the society. So this project was started. Let me make a self-introduction. My first meeting with Beringia is that when I visited Toronto University as a foreign exchange student, I studied under Professor William Irving. And Beringia Symposia was held in Japan and is held. And why? Because this has the possibility of supportive data cooperative research with Japan. And when humans crossed over to the America, Japan was experiencing a major change. Before that, the people lived in internal land. However, they were trying to move into the coastal environments. And also in Japan, research results of lithic tool production, particularly microlithic blade techniques, could contribute a lot to lithic research in Beringia. And the third one, which is not known so much, but access to a store of archaeological research by Japanese scholars in eastern Russia, extending back to the beginning of the 20th century. And these is going to be explained. This is the terminology. Here, the Americas, that means North America and South American continents. So not the United States only, the Americas, North and South. And early people, that is the first humans to enter the Americas. Early people, that is the early man or first Americans and so on. And calendar year before present, such and such BP is used, but BC AD is much easier to understand for layman. Then just subtracting 2,000 years. And then 4,000 calendar year BP is about 2,000 BC. That's the calculation formula. And the Arctic. Here, the Arctic is defined as northern latitude tundra environment. So tundra environment. Well, when carbon-14 dates are not available for human groups, then molecular dating is substituted. What is the Beringia? Well, in Japan, it's not so well recognized. So about 34,000 or 12,000 calendar year BP. Sea level lowered more than 120 meters. Then the largest expansion of area is the dotted line, so those will be exposed. That is the land of Beringia. Simply speaking, from the Chukchi, Kamchatka Peninsula, and Kurma River, Mackenzie River. So you can see this is expansion. Why Beringia is attracting a lot of attention recently? As Professor Matsumoto said, we are focusing on first America people. When the modern people are moving to the Americas, Beringia was the gate. In Japan, Norman elephant was still walking, and as I said before, people used to have the culture in internal land of Japan, but they were trying to expand to the coastal area, and especially north part of Japan, it was connected to Asian continent. So therefore, from Hokkaido to Alaska, people were able to walk. Simply speaking, where did early people originate? That is, from the northeast Siberia. For human colonization was made in northeast Siberia. That was 40,000 calendar year. Some people say 30,000, but I believe in 40,000. And the most ancient northern Siberians, ANS, they are the oldest. They lived in 40,000 to 25,000 years, and the Yana River is presently the only known site up to date. And one more Siberians are ancient Paleo-Siberians. That means they branched from the origin. From 25,000 to 10,000 years is the range. And they are the matrix of early people that entered into the America. We will not touch upon the third one, that's the Neo-Siberians. There was a group living in 10,000 calendar year BP. So all those had the animation. It was supposed to move, but it doesn't look so. ANS, the 40,000 years ago, that's the oldest one. And the only remain is Yana, RSHS. And in Alaska, Swan Point is another one. I will touch upon this later. Paleo-Siberians. That means after ancient North Siberians, we have the Paleo-Siberians and ancestral Native Americans. They came in the range of 25,000, 10,000 years ago, and they are moving to the America. Yana RHS is located here. Well-known old site, 31,600 years ago. This is the ANS cultural site. In the year 14,100 calendar year was the Swan Point in Alaska, but between the two, we do not have any more sites. So, unique genome was obtained by these occupants. But of course, we have the assumption that they used to live here, but we don't know what they were doing. Maybe today and tomorrow we will challenge this issue. Simply speaking, here's a long distance. 17,000 years is the difference. 75,000 kilometers, and then 7,500 kilometers separated by time and space, but no sites yet known for this temporal and geographical hiatus. And how to classify the people for the early people in the America? Now, the very strict belief that Clovis first. This is the advocates in some group. Clovis first has the unique projectile points. Still, people claim that that was the oldest, but the Paleo-Indian have presented many sites, and the Paleo-Indian period was up to 16,000 calendar year BP, so this was called as pre-Clovis. And there were debates, but in South Pacific, or for South America, in Monteverde, Paleo-Indian sites were widely supported, and more sites were found year by year. In a way, the focus of debate is more than 16,000 years ago. Those sites are really the true sites or not. So those were the debate. But we do find more but for the authenticity of the sites, we will have more of the debate. Another one is that when we talk about the Beringia, always we face the Beringian standstill model. In Beringia, people stand still, reside, and isolated. This BSM is the concept that there is not the genetic exchange in those areas. From ancient Paleo-Siberians, early people genetically diverged from APS and developed respective genomes like these. Many in the early people moving to the America have these characteristics of these haplotypes. In Beringian period, no Beringian sites known for the postulated BSM. There is no sites for BSM. We do have some candidates, however, whether that is the really authentic sites or not, so it's still under debate. Another one is that for those haplotypes, where were they emerged in Beringia? Or we will take up the issue Hokkaido, Kurilo area, or after American continent. Then by what route did early people disseminate into the Americas? Most famous one is the inland ice-free corridor. That means Laurentide ice sheets and the Corallian ice sheets are there, and in between there is a corridor. Ice sheet got thinner, receded, then a corridor became open. But sometimes it was blocked. Then people cannot move. And in North Pacific, this is the coastal route. Again, a lot of discussion has been made for this route as an option. While ice-free corridor was blocked, maybe people used the maritime route, or they had the selection of the two according to their will. So what are the remaining issues? Humans dispersed into the Arctic environment and adapted new genome. That was about 40,000 years ago, and about 38,000 years ago, new haplotype developed. And for those people in Beringia, for several thousand years or several tens of thousand years, they stayed during the standstill. Then distinctive genome haplotype appeared, and those people moved to the Americas. Was that just one wave, or two waves, three waves, or more than those, four waves? Well, again, at this symposium, we can discuss on this topic. One thing that we should remember is that not the unilateral direction from east to west only, but from the American continents, some were reversed back to the Siberian. So reverse should have been occurred. So that's all. Thank you very much.
Honda 先生、どうもありがとうございました。では、次に
Thank you very much, Professor Honda. Next, one of the organizers of the symposium would like to welcome Professor Ben Potter. And Professor Potter will give us the introduction for the symposium upcoming 2 days.
So am I audible? Awesome. Oh, great. You may see this image again. So good morning, everyone. I want to welcome everyone to the conference on the late Pleistocene peopling of Northeast Asia, Beringia, and the Americas. I want to thank Professor Matsumoto and the Out of Eurasia Grant and Aid for the funding, allowing us to travel here to meet and discuss these important topics. I also thank my co-organizer, Professor Honda, who has worked with me for over 2 years to make this event happen over the course of the pandemic. And thanks to each speaker who is attending to present their research. So when Professor Honda and I first discussed the need for this event, we highlighted connections that need to be strengthened as we collectively try to understand the peopling of these regions. There is emerging complexity on both sides of the archaeological and genetic records. There are new ideas and a multiplicity of hypotheses and models to explain the emerging patterns. The problem is intercontinental and international in scope, and scholars, often bound by the language they publish in, are somewhat hampered in obtaining the most up-to-date consensus within each sphere. Furthermore, we saw many competing models and mutually exclusive hypotheses, which is great. This allows for falsifiability and testing against new data. Professor Honda has just given a brief overview, and with my introduction, I hope to provide the public audience and the later YouTube audience with an adequate background and context on the problems we'll discuss today and tomorrow, lay out relevant data, major points of agreement, and identify major points of disagreement. The field is now in an interesting state from our perspective. Old ideas that were once solidified have been toppled, and yet a new consensus has not yet emerged. New discoveries and controversies have made the topic very interesting and exciting in recent years. Ancient genetics has generated new ideas, but is yet to be well integrated within archaeological data sets. There are major competing models of the peopling that are unresolved. When did Native American ancestors migrate to Beringia and the rest of the Americas? What routes did they take? Are early stem projectile points in the Americas connected with stem points in Japan? Were there earlier expansions into the Americas, perhaps before 24,000 years ago? What role did humans have in the extinction of Ice Age megafauna? What role did climate play in human expansions in the far north? Many ideas are on the table. There are many similarities in the archaeology of Japan, Beringia, and the early Americas. We face similar problems of interpreting human adaptation to now extinct environments. Ancient peoples used similar sophisticated stone tool technology, such as microblades, beer ends, and bifacial points. Using our different perspectives and data sets, we have the potential to strengthen our hypotheses, make them more rigorous. We can learn from advances in method and theory in both Japan and in the West, advances in method and theory. In addition, there's the possibility of actual historical connections among populations in these regions. So in this talk, I want to highlight the significance of these problems we'll explore and provide a background to the audience who are not specialists. I'll describe the paleoenvironments and chronologies of the last ice age and the modern period. We'll look at modern cultural and linguistic groups on both sides of the Bering Straits. And then I'll spend more time on the archaeology and genetics of these regions, focusing on where there's widespread agreement, where we generally concur. I'll also point out where there are disagreements, and there are many. There's also healthy debate on the migration route or routes early people used. And finally, I'll end with posing some unresolved questions that bring us to Kyoto for this event. There are a number of reasons why this particular archaeological problem is significant and relevant beyond our field. First, the high latitudes are among the last habitats to be colonized by anatomically modern humans, and thus provided severe challenges to human technological and behavioral innovations. Understanding how this colonization process occurred helps us examine humans at the edges of survival. How do humans adapt when faced with extreme environmental conditions? And how can we characterize human-environment interaction as it relates to global climate change over the last 30,000 years? These questions are tractable with the data we consider at this conference. Second, studies of these ancient hunter-gatherers indicate they were very different than most modern foragers worldwide. They used some of the most sophisticated stone and organic technologies, had very low populations, very low densities, very large seasonal and annual territories, and extremely high residential mobility. As we spent 99% of our time as a species, as small populations of hunter-gatherers, it behooves us to understand this major human adaptation, one that allowed for migration into vast new territories and unfamiliar landscapes. Third, we find ourselves in a world experiencing dramatic climate change over a relatively short period, affected by anthropogenic factors. The Earth is warming, particularly in high latitude regions like the Arctic, and I've experienced it in Alaska over the last 25 years. The last period of warming occurred during the deglaciation and the transition to the Holocene between 16,000 and 11,500 years ago, coinciding with the peopling of the Americas. Today and then, we observe vegetational change and animal extinctions. The first colonizers made decisions in a period of climate change as they attempted to adapt to changing local environments, seeded or scaled across 3 continents. Climate change dramatically affected the far north, and we'll see examples of long-term resilient adaptive strategies employed. And finally, this problem centers on the heritage of millions of people on 2 continents. Their story is profound and significant to examine in all of its complications. So let's start this examination with the landscapes they encountered. Regions we're considering here are Siberia, the east-west extent defined by the Urals and the Verkhoyansk ranges, north-south extent defined by the Arctic Ocean and the southern Altai and Sayan mountains. The Russian Far East extends from the Amur Basin to Chukotka, and Beringia overlaps this, typically defined from the Verkhoyansk range to the western limits of the Laurentide and Cordilleran ice sheets. With sea levels lowered, the land bridge is apparent, making Alaska an extension of Asia, and most of my work is in Alaska. Large northern rivers drain 3 distinct geomorphic zones. The southern Siberian highlands comprise plateaus and mountains with complex vegetation and variable fauna. The subarctic comprises rather flat terrain, terraced river systems, and homogeneous boreal forest, or taiga, and the flat treeless tundra in the north and east. The climate of Beringia is hypercontinental, with very cold, arid winters and mild, moister summers, and this extends to eastern Beringia, Alaska, and the Yukon, where we have southern mountain ranges, an interior boreal forest, and northern alpine tundra biomes. During the late Pleistocene, or last ice age, these areas were colder and largely drier than they are now. Glaciers are present, but minor in scope, and they did not appear to present major barriers to movement. More meaningful was the decrease in moisture, where the taiga thinned out, and we see tundra and steppe expand into a new steppe tundra biome associated with large gregarious grazers like mammoth, horse, and bison, the mammoth steppe. I want to briefly summarize paleoclimate and the overall chronology we'll be examining. This graph illustrates temperature on the y-axis measured from a Greenland ice core. Blue is colder and red is warmer. The x-axis goes from 50,000 years ago to the present, and we can see distinct periods of climate change. The first is marine isotope stage 3, or MIS3. It is an interstadial or warm period dating from 50 to 26,000 years ago. There were fluctuating climates with greater seasonal variation, but broadly fewer glaciers, warmer, moister with forest that fragmented grazer habitat, generating mosaics of vegetation regimes. During this period, the first modern humans entered into southern Siberia and eventually expanded as far north as the Yana site. MIS2 is a glacial or cold period dating from 26,000 to the end of the Pleistocene at around 11,650 years ago. MIS1 is the modern Holocene interstadial or warm period. I'm going to zoom in on this area. MIS2 can be broken into different chronozones that are likely part of our discussion. The last glacial maximum, or LGM, dates to 26 to 18,000 years ago, associated with expanding glaciers and glacial barriers, extreme hypercontinentality, a polar desert in the far north. In unglaciated areas, like interior river valleys, we see decreased mosaics and greater habitat uniformity, namely steppe tundra, and decreased seasonal offsets. After the LGM, we see the onset of decreased glaciation with increasing warming and amelioration of climate, encompassing the Bowling and Alarad interstadials. This is shown as B/A. From 14,700 to 12,900 years ago, we see decreasing glaciers, opening up of new habitats, and the onset of land bridge flooding, decreased continentality, and increased seasonal offsets. After these interstadials, we observe a final brief cold dry period termed the Younger Dryas, between 12,009 and 11,650 BP. And then finally, we have MIS1, also known as the Holocene, which we're still in. We see moister, warmer conditions that drove the spread of boreal forest across interior Beringia, Siberia, and Alaska, resulting in the modern conditions we observe today. With respect to Ice Age conditions, the steppe tundra, we have no clear modern analogs, and it is difficult to interpret. But this is considered to have been very productive, supporting numerous megafaunal species that would have been attractive to early hunter-gatherers. Indeed, climate has been used as a driver to discuss human behavior, such as migrations, expansions, new technologies, and economic change. One important element that remains hotly debated is megafaunal extinctions at the end of MIS2. Dozens of genera, particularly large and very large mammals, became extinct, from mammoth, other proboscideans, horse, giant ground sloths, American camels, etc., as well as their predators, like American lions, cheetahs, and saber-toothed cats. The role of human overkill of some of these fauna remains unresolved. Some have argued that it was climate, some argue it was human pressure, and some argue that it was both. So now we have an idea of geography and climate. Let's turn to the people. It's a language map of North America. One way to consider the problem is to look at recent and modern population distributions, because a lot of the genetics are coming based on self-identified linguistic groups. On the North American side, we have Yupik, Inupiat, and Aleut people, shown in yellow. These are recent arrivals around 5,000 years ago. Further south, Na-Dene peoples, like Dene, Eyak, and Tlingit, form a large block, and they're shown as olive green. Beyond are hundreds of distinct language groups that have no connections to Asia. I've worked with Ed Vida on the proposed historical link between Yeniseian or Ket speakers in central Siberia and Na-Dene. Given Dene connections with 6,000 years of interior subarctic prehistory, it's difficult to evaluate how and when they were connected, but it could be very ancient. Thus, beyond this, there are no clear historical connections between the continents. On the Asian side, there has been substantial turnover in indigenous populations, with the historically recent migrations of Turkic-speaking Sakha and Tungusic-speaking Evyen peoples largely replacing earlier Siberians. Yukagir is a remnant of one such earlier group, but they have been linked to Samoyedic speakers further west, like Ninsi, Selkup, and Naganasan. Chukchi-Kamchatkan-speaking groups include Chukchi, Koryak, and Itelmen that have been linked with Eskimo Aleut peoples by Michael Fortescue and others. So this black area shows our lack of knowledge about Siberian populations prior to just a few hundred years ago. Vast stretches of Siberia remain effectively unknown with respect to earlier groups. We don't know their linguistic or cultural affiliation from the Iron Age all the way to the Paleolithic. And there are no unequivocal linkages of languages between Asia and the Americas, with the exception of Dene Yeniseian. So turning to archaeology. In terms of the archaeology of Northern Eurasia and the Americas, there is an apparent gaping discontinuity. This disparity between Siberian late Upper Paleolithic and the American Paleo-Indian lithic industries is what has largely hampered identifying linkages between continents. In Northeast Asia, these lithic industries are largely characterized by complex microcore, microblade, and burin industries, while early Paleo-Indian complexes are typified by fluted and unfluted bifacial projectile points and the absence of microblade technology. The Beringian record, notably in Alaska, bridges these continents, but in complicated ways, such as the very late occurrence of fluted bifaces and the pre-Clovis occurrence of microcores of the Yubetsu type. There is consensus that the first widespread cultural manifestation south of the ice sheets is the Clovis complex of North America and the probably related fishtail complex of South America. Both are continent-wide and are associated with distinctive technologies suggestive of a colonizing population. No later complexes has such broad distributions, and these are dating around 13,000 to 12,800 for Clovis and after 12,900 for fishtail points. The so-called Clovis first hypothesis held that Clovis represented the very first Americans, present only after these dates. However, there have been numerous sites reported to be earlier than these complexes. So we'll take them in stages. Many of them have been rejected by the scientific community. We don't hear about Calico, Old Crow, Monteverde 1, Pique Mache, and many others. Others still retain adherents, such as Bluefish Caves, Pedro Ferrada, Meadowcroft, and Topper, despite much criticism. And over the past 2 years, several high-profile purported early sites have been reported, like the Surudi Mastodon, Chiquihita Cave, and the Hartley Mammoth, suggesting human occupations 25,000, 37,000, and even 130,000 years ago. I think collectively here, most of us have issues with these purported sites, and most of the criticism has to do with directly associating secure dates with unequivocal human activity. I was part of a group of scholars that tested the Chiquihita assemblage data and concluded that they were probably naturally occurring geofacts. That said, there is a more widely accepted group of pre-Clovis sites that generally date after 14,800 years ago, including Monteverde 2, Paisley Caves, Paige Latson, Deborah Friedkin, Wally's Beach, El Fin del Mundo, and others. And a few sites may or may not date slightly earlier, such as Galt or Cooper's Ferry. Suffice to say, much of the disagreement on modeling the peopling of the Americas has to do with which sites and ages are considered valid or not. And I suspect we won't have 100% agreement in our group of scholars on all of these latter sites, though we may agree on many of the pre-16,000-year-old sites. One exception is maybe the recently published White Sands footprint site in New Mexico, and one of the principal investigators is here with us, Dr. Dan Odes. If the dating is correct, it represents unmistakable evidence of human occupation in the Americas about 23,000 years ago during the LGM. Another model has been raised positing an early coastal migration associated with early stemmed points, coeval with Clovis or maybe earlier, and perhaps connected with Japanese stemmed or tang point traditions. A 13,000-year-old stem point site at Ushki Lake in Kamchatka has been considered by some to represent remnants of this non-microblade bifacial tradition near the coast. Now let's turn to genetics. Since 2007, the field of archaeogenetics has revolutionized our understanding of the colonization of Northeast Asia and the Americas. And this field represents powerful new tools to address complex relationships among ancient peoples. However, we're still hampered by very small sample sizes, as this recent figure shows. Later, Dr. Sakura and Dr. Oto will present detailed reviews of current research from genetic perspectives. For this introduction, I wanted to provide a broad summary of genetic patterns from an archaeological perspective, as well as highlight areas of agreement and disagreement. Broadly, I believe the ancient genetics literature is coalescing into a cohesive whole that broadly corresponds to much of the archaeological record in both regions, and this is an important point of consilience. So we'll be on this slide for a while. So we'll begin with a very simplified version. This is a very simplified version of ancient populations we've discovered. This has been the biggest surprise that genetics has given us, the discovery of multiple groups that we didn't know about from an archaeological settings. Here we have calendar years before present, and in white is the last glacial maximum, or LGM. All modern and ancient Native Americans derive from a single founding population termed First Americans, or FAM. So when I use FAM, I'm talking about this first group. This group began diverging from ancient East Asians about 36,000 years ago, with strong gene flow until about 25,000 years ago. Surprisingly, about 25% of Native American genes derive from a separate source termed ancient North Eurasians. This admixture occurred sometime between 24 and 20,000 years ago. And there is strong structure among early Native Americans with three basal groups: ancient Beringians, which remained in the far north, and two others, North and South Native Americans. We'll call them NNA and SNA. SNA is associated with the rapid star-like radiation following a period of genetic isolation. So this is the framework I think that we are generally getting from the genetic data. In a 2018 paper, two different Siberian groups were identified: Paleo-Siberians, who separated from Native American ancestors about 24,000 years ago, but remained in Siberia, where they were largely replaced or admixed with Neo-Siberians in the Holocene. These latter were more closely associated with East Asians, like the Han. Now, these Paleo-Siberians also cluster with Paleo-Eskimo and are likely the source of the later spread of Eskimo Aleut peoples in the Arctic. Later in the Holocene, an unknown Asian population exchanged genes with Na-Dene people, part of NNA, and the source of this is debated, perhaps an unknown group related to modern Koryak or a Paleo-Siberian group related to Sakak. We don't know. While genetic analyses are great at identifying groups and split times, they're less suitable for identifying geographic locations in the past. And here are the earliest known ancient samples for these populations, shown as stars. We can see we have no ancient sample locations for the North American ancestors before Anzic at 12,800 or 900 years ago. The critical period for us is between 25,000 and 14,000, and we have no early samples for this period. The dated samples, however, do represent anchor points that we can use. One more recent discovery, the genomic analyses of 3 Jamon individuals, show definitively that Jamon ancestors diverged from other East Asians prior to Native American divergence. And there's also little connection to ancient North Siberians. Thus, Jamon at present appear unrelated to the peopling of the Americas, but that could change with new samples. Besides genomic analyses, mtDNA and y-DNA, inherited exclusively from mothers and fathers respectively, have yielded robust patterns. Here we see effective population, female population on the y-axis, and years before present, and thousands of years on the x-axis. Mitogenomic analyses by Lamas et al. Indicate a population bottleneck of Native American ancestors prior to a large population increase between 15 and 13,000 years ago, and this also aligns with a period of increasing mtDNA haplogroup diversity. This clearly indicates the radiation of new lineages in the Americas, and it squares nicely, broadly, with the archaeological record. Using different data, in this case y-DNA, Wei et al. Found similar patterns. The 3 founding Y chromosome lineages for Native Americans differentiated in Siberia between 17 and 15,000 years ago, and they identified a narrow time frame for the upper time limit for human entry into the Americas between 15,300 and 14,300 years ago, again, according well with the mtDNA and with the archaeology. And in 2019, Panadi et al. Corroborated these results, inferring male lineage expansion after 15,000 in a radial or a starburst-like manner, suggesting rapid expansion. The last main topic I wanted to cover, summarize, was probably the most contentious after the timing, and that's the routes used, or more specifically, their geographic locations during periods of interaction with other populations, periods of genetic isolation, and routes of colonization through these regions. In a series of maps, I'll sketch out what I hope, please be gentle, is relatively uncontentious about these patterns, and then highlight where I think main differences of opinion reside. And we can think of the problem in phases. So we'll start with the 36,000 year to 25,000 year period. So the first phase is the divergence of FAM, or First Americans, from their East Asian source. This took place during the MIS-3 interstadial, and each location I think is very speculative unless there are anchor points. So think of them as placeholders for now. There was a long period of gene flow where they were still interacting. At the same time, there were different populations to the north, ancient North Eurasians associated with the Malta individual, and ancient North Siberians, a related group associated with the Yana individual, dating to 32,000 years ago. This group was associated with the Siberian Middle Upper Paleolithic, and Dr. Hofecker will probably address some of this in more detail later. We don't know where FAM were located during this early state, but apparently not close enough to admix with either ANS or ANE. So I put them further to the south. Between 25 and 20,000 years ago, there were a number of important genetic events, but unfortunately we have no anchor points, except for Afantova at around 17,000, showing that the location of ANE was pretty constant in southern Siberia. The MIS-2 last glacial maximum is evident here in ice extent, and I haven't shown the Asian glaciers, but they were less extensive. Native Americans were genetically isolated from East Asians after 24,000 years ago, but they did admix with ancient North Eurasians between 24 and 20,000 years ago. And at the same time, Paleo-Siberians marked PS began to diverge from East Asians, and they also admixed with these ANE groups. And note White Sands and Bluefish Caves will be sites we'll be talking about during the conference, during this time period. So this is probably the most contentious and widely debated part of the record, between 20,000 and 16,000. This is the period of the Beringian standstill, where FAM were genetically isolated from other East Asian populations. We don't know where they were located, and we have no anchor points during this period, and no genetic samples. Some have argued that they were in Trans-Baikal, maybe the Lena, maybe the upper or lower Amur Basin, maybe Primoria, maybe Sakhalin, Hokkaido, Kuril Peninsula, central Beringia, or the southern coast of Beringia, or maybe in North America. Hopefully we can have a lively dialogue on this. Sometime after 16,000 and before 13,000, FAM, so it's a very wide time range, FAM at this point comprised of multiple groups expanded into the Americas south of the ice sheets. The genomic, Y-DNA, and mtDNA results all coalesce. There are also a number of archaeological cultures in Northeast Asia, the Afontova-Kokorevo tradition around Lake Baikal, and then Dyuktai culture expanding into the Lena and into western Beringia, and incipient Jomon in Japan following a transition from the Japanese terminal Upper Paleolithic. Unfortunately, again, we have no human remains during this period except for a newly reported individual UKY who appears related to Paleo-Siberian but is the closest cousin to FAM in Siberia. The routes that FAM took in their migration or migrations into eastern Beringia and south of the Laurentide and Cordilleran ice sheets is also unknown, and there's been considerable healthy debate. One route is through an emerging ice-free corridor between the ice sheets. Another is along the southern Beringian coast and northwest Pacific coast, so interior and coastal routes, and both may have been used. In brief, the proponents of the primarily coastal route cite early southern occupations prior to the availability of the ice-free corridor. The timing on the opening and biological viability of each route has seen a lot of work over the last 5 years, even with the pandemic. While there are differences of opinion, the ice-free corridors appear ice and proglacial lake free by at least 15,000. Cool. While the coastal route would have been traversable earlier, perhaps as early as 17,000. Depending on the pre-Clovis site ages one accepts or rejects, the interior route could be accepted or rejected. And then I'll speed through this end. I think I'm good. So here is the ancient genomes where we do have anchor points, and this is later in time. We have some samples that help elucidate where they were. USR 1 and 2 and Trail Creek Caves indicate ancient Beringians remained in the far north. NNA appears to have long-term continuity on the northwest coast, and SNA spread throughout the rest of North and South America in a rapid star-like radiation. This means rapidly diversifying sublineages consistent with an initial colonization. The split times within SNA also appear to correspond broadly to the archaeology between 14,000 between Anzac and Spirit Cave with Lago Asanta, ancient South American individuals, 13,900 BP split with Lago Asanta and Central Americans, and then finally 12,900 years ago is the split of Lago Asanta and modern South Americans. This appears consistent with the north to south expansion. So for the translator, I'm skipping to the last section since I have limited time. So where do we stand? I've sketched out some patterns that I think we accept to some extent, and there are many more areas of unresolved issues. In no particular order, first, the source location of FAM prior to 13,000 years ago. This is totally unknown. It may be anywhere from Trans-Baikal to Japan to Beringia. Obviously, rates of expansion and association with climate change will rely on firm locations and chronology. The evidence of population expansion and diversification we see from the genetics have different meanings if the expansion started from southern Siberia or if it started from Beringia. We're going to have different issues. The duration and the location of the so-called Beringian standstill. 3, timing of the earliest peoples south of the ice sheets. 4th, migration routes from Asia to Beringia and from Beringia to the Americas south of the ice sheets. This has profound implications not only for the lifeways of the early inhabitants, but also for our anthropological understanding of colonization processes. 5, the role of early Americans in megafaunal extinctions. And 6, where and when did hypothetical population-wise admixture with some FAM ancestors occur? So I skipped that with the genetics. There are some ghost lineages, possible hints of early populations for which we have no human remains, we have no direct samples, and we don't know very much about population Y. What did the admixture occur in Asia among early FAM, or were they a remnant of an earlier migration? We don't know. 7, did ancient North Siberians, yep, I'm just about done. Did ancient North Siberians at Yana continue west into the Beringia and the Americas? They went very far north. They could easily have traversed Beringia. And finally, the role of Japan in the peopling of the Americas appears to be currently unknown. Such a role would be inferred if historical connections and stem points are demonstrated between Japan and the Americas. Alternatively, if White Sands represents an LGM occupation, then while Jamon might be genetically distant from Native Americans, the earlier Japanese terminal Upper Paleolithic peoples might provide a genetic source and origin. Thank you.
Thank you very much, Dr. Potter, for your introduction, which has clarified the purpose of our symposium and gave us some important basic facts related to the theme of the symposium. Now, please give me a few more minutes before closing this morning session. Well, thank you very much for all the speakers and all the participants. Dr. Hirasawa kindly has brought some snacks for us, and that is on the table at the rear corner of this room, so please help yourself. And I have some announcements to the speakers. Please try not to speak too fast because today we have simultaneous translations. But due to the very tight schedule, please remind that you, don't exceed your time. And at this symposium, we have very high-tech system to control the presentation time. There is a 3-light machine on this speaker's table, and the green lights is on when you start speaking, and when it turns yellow, it means that you have 3 minutes left, and when it's red, it means that your time is over. So please try to meet the time. And I think that's all for me to say now. And so I'd like to close this introductory morning session. And the first session starts at 1 p.m. So please come back to this room by then. Okay, please enjoy your lunch. Thank you very much.